Hey, what's up, guys? Uh, Chung here again. So this time, let's take a look at another LeetCode problem here. Uh, Number 358. Rearrange string k distance apart. Okay, so you're given like a string, right? And a distance k here. Rearrange the string so that the same number, I'm sorry, the same character, the distance is at the minimum of k, right? If you cannot rearrange in such way, just return empty, right? For example, if you have this AABBCC and the distance is k, right? So the way you can rearrange it is from the uh, I think it doesn't say anything about the sequence here. So basically the one way is like A, B, C, and A, B, C, right? So that A, the distance between two A's is 3, between two B's is also 3, same for the C, right? And for example, for this one, say A, B, and C. So the the range K, the the distance we need here is 3, but there is no way we can rearrange the string in such way. So that's why uh we return like empty string. Okay. Same for this one. A, B, C, A, B, C, D. Okay. So, okay. So the the idea of this problem is we need to have a dictionary basically. The dictionary will store each character's uh each character's uh counter, and every time we uh we always get the character whose counter is the we always get the character who has the most count, right? For example here, uh, for example this one here. So we have a A3, right? And then what B is 2, C is 2, and D is 1, right? So every time, since we need to have a case distance, right? So basically every time we get a case most uh case like character whose count is the most. For example, if the k equals to 2, right? So basically we'll get A and B first, right? So A and B. After that, we will insert this thing back to the priority queue. Basically, we'll use a priority queue to store the the most the character who has the most count, right? And then so once this is done, so this becomes to 1, and this become A becomes to 2, and B becomes to 1, right? So the next time, right? The next time we basically this will be a rearrange, and the next time we're also getting the the biggest the first two characters who has the most counter here. So in this case, it's gonna be those two A and C, right? So A and C. right? And then after that, this one, this A will become to 1, right? And C will become to 1 as well, right? And then the next time, right, it's going to be A and B, right? A and B and what? And then C and D, right? That's how we come up with this solution here. So, I mean, by using a priority queue and counter, it's kind of intuitive. It's not that hard, but there's there's like a corner case we need to take into account. For example, how can we like check when should we return the empty, right? When's the conditions that we can tell, okay, so there's the like there's no way we can continue, right? And I think my way of checking it is the if if the length if the length of the queue, the priority queue, is smaller than k, and the priority queue, the first priority queue, and the counter is greater than 1, it's greater than 1, then I return I return the empty string here, right? So why I have the second one? The first the first condition is kind of intuitive because uh in this case, right? Uh or let's say yeah, let's say there's a like a uh, a a and b, okay, right? And then the k equals to 3, right? So in this case, there's no way we can come up with a rearrange, right? Because there's a priority queue. Basically, I store the unique integer, sorry, the unique characters in this priority queue. So in this case, in the priority queue, they're gonna be like two elements. One is for A, second one is for B, and the length of the priority queue is 2, which is smaller than K. Then I know, okay, it's it's not valid, right? And but if you look at this one, remember, so how we come up with this like uh come up with this like string here. So by the time we were at C and D, by the time we were processing C and D here, every time, right? Every time we uh so there's no way we can uh C and D, C and D. So B, C, C, D. Okay, yeah, sorry. For example, this one here. Let's say uh basically this is false, right? And how about this? A uh B, A, B, C, okay? And K is equal to 3, right? How about in this case? Let's say right now, right? Let's see we have the first time we'll be having like A, B, and C, right? We'll be having A, B, and C in the priority queue, right? And once we process the first case numbers here, we have A, B, C in the end. But then the B and C only has only one B and one C. So once we uh, process the first case, the B and C is gone, right? And then there's only one A left in this priority queue, right? But the length of the priority queue is smaller than K, right? But can we say this is like not a valid rearrangement? No, right? Because this is still because this A is the last element, right? So that's why I add a second condition here. So when this length of priority queue is less than K and the first element, since the priority queue is from the most to the least, right? So if the first one has more than one values, and then I know, okay, there this element, so this first character cannot be separated, right? Uh, okay, so with that in mind, let's start coding here. All right, so basically we're gonna have a counter here, right? Counter is gonna be collections. Basically, I'm using one counters and one a priority queues. Two data structure here. Uh, counter, right? S. Now I have this thing here, and then I'm gonna create a priority queue here, right? So the queue I'm going to store a tuple in here. Basically, the tuple I'm storing here is the counter and sorry is the character and its counter. Since we're going to sort by the number of the count, I'm going to put the counter at the first element and then the character at the second element, right? For the counter counter dots the values of C, right? For C in counter, right? That's the priority queue. But remember, since we're doing, in the Python, the priority queue is the stores the minimum number at the beginning, right? But what we want is the maximum, right? So we simply use a small trick here. We do a negative of counter, right? So that's how we convert this minimum queue to a maximum queue. And then we do a basically we just sort, right? Heap queue dot heapify, right? Heapify this priority queue, right? And then basically it's just simple sorting here. And then uh, I'm gonna have an answer here. Answer will be the final result, right? So when do we stop? We stop when there's nothing left in this priority queue, right? Okay, so since every time we need to pop case characters, I'm gonna create a temp list here at the beginning to store to, a, to have a temporary place to store all those characters we have popped this time, right? And then, like I said, so if the uh, if the length PQ is smaller than K, and right, and this like the first element in the priority queue, right? And the first one is the counter, but we also need to do a minus since we are storing the minus value is greater than one, right? Then we return basically empty, right? Otherwise, we just simply pop case number, right? Uh, otherwise, we just pop for, we don't need the index here, in range. k. Oh, sorry. So here, we instead of k, we need to use like the minimum of the k and the length of priority queue, right? Because in the end, even though there might be like k equals to 3, but at this moment we might only have like one element left in the queue. So if we do a case here, right? I believe the heap pop basically will throw an exception. Yeah, so because here we're gonna have like a pop, right? We're gonna pop case times, right? So current item, let's do a current item equals to a heap queue dot heap pop, right? Priority queue. If we don't limits do a limit check here. So when let's say when there's less when the priority queue only has less item than the queue, and we'll be having like an index exception here when we try to pop like an empty queue here. That's why I do a range check here to make sure will not end up with an exception. Right, so what do we do here? Uh, okay, first answer, right? And since we have the current item here, so we're gonna do a count. What's the count? I'm just defining several like variables here to help me do the following calculation here. So the first element is the right. The first element is the count. Since we're using like a negative value, so I'm gonna to convert it back to the positive value, and then the character is the second one, right? So the second one is just like a string. Okay. So and then now since we every time we have this answer, we do a answer plus, right? C. That's where we append to our final result, and then we do a count -1, right? -1, and then we're gonna save this thing back to the temp list. So the reason that we need a temporary list here, we don't want to push it back to the heap queue because we don't want to this. So if A has a lot of many characters, the moment we put it back, the next time it will be picked up again, basically, right? So that's why we don't want the same like same characters got picked up twice. That's why we won't we won't push it back until we finish processing all the case character here. That's why we do okay. So first we do a simple check, right? So if the count is greater than 1, then we push it back. Otherwise, there's no need to push it back, right? If count, then I for now I just simply append this thing to the current C to the to this temporary list here. And then once this is finished, right? And then for count C, then it's time for us to push those things, whatever left, back to the priority queue. In temp list, right? Heap queue dot heap push, right? Priority queue, and now we also need to change it back to the negative value, okay? And then we simply return the answer, right? So that should just work, but there's one more, uh, there's one corner case we didn't take into account. So when k equals to 0, right? So when k equals to 0, what's going to happen here? If k equals to 0 and we follow our code here, right? Uh, so what's going to happen? Let's see. So what's going to happen is since is equal to 0 and this for loop will never happen basically, right? Because is 0 and so range minimum the length and this one. So this range will always end up with 0, which means we'll never pop anything from the priority queue. Basically, this thing will end up in the infinite loop, right? So that's why we need to check if k equals to 0 at the beginning. So what does it mean? So so what does a k equals 0 mean to us? It means that uh, 0 distance between each character, which means we don't need to do anything, right? So which means if there, even though it's a, right, and k equals to 0, it means that we don't need any distance between any of the letters here, which means we don't need to rearrange anything. We can just simply return the original string here, right? So that's why we simply return an s here. So yeah, I think that should do it. Let's just return. Uh, did I make a mistake here? Maybe too many parentheses here. No, here. Sorry, minimum k. Okay. All right. Let's submit it. Cool. So it passed. All right. So yeah, basically, uh, I use counters plus the priority queue with a tuple to keep track of what are the current strings I need to use to concatenate to the final answer here. And this is where how I check if if this string is a valid string that can be rearranged with k distance. I believe there must be some other ways of checking this thing, but at least this is how I check it. I find it. It took me a while to find out because I was trying to check this like empty string at the beginning, but it didn't work. So in the end, I finally find out a solution here by using this thing along with that to return empty here. And other than that, it's just a regular uh, priority queue to pop it and then use a temporary list. And then in the end, I push them back, right? In the end, just return the answer. Okay, cool guys. I think that's it for this problem. Okay, I forgot to give it my own upvote. Mm, yeah, and I hope you guys enjoyed. Thank you so much. All right, see you guys. Bye bye.